Welcome to my presentation on multi-class big data classification using distributed and MapReduce methodology. In today's digital era, data mining has become an essential tool for businesses and organizations to basically extract valuable insights and patterns from massive amounts of data. However, with the increasing size and complexity of these data sets, the existing traditional data mining techniques are not sufficient, and parallel computing techniques are required to process and analyze data effectively. So, this paper aims to compare and analyze the performance and efficiency of two parallel computing methodologies, that is the distributed procedure and MapReduce based procedure on on large multi-class datasets. This study focuses on evaluating the accuracy and processing time of support vector machine, that is SVM classifiers, using the above two procedures. So let's move on to the next slide. So in the following slides, I will provide an overview of the background, the data mining process, in particular the distributed and MapReduce based mining process, the implementation, which includes the dataset description, system and software requirements, what are the system and software that we used in this particular study, uh, and the experimental results of the study. That is, the findings on the cover type dataset and the findings on the person activity dataset. I will also discuss the limitation and future direction for this research. So let's dive in. The field of data mining has seen significant growth in recent years due to the rapid increase in the amount of available data. So from various sources, many companies are collecting huge amounts of data. So the sheer volume of data that is being generated on a daily basis, it presents a lot of challenges, including the need for efficient processing and analysis method. So data mining provides a means to extract valuable insight from these large data sets. So with the goal of uncovering pattern and trend that can inform decision making process. Exponential growth of data has made it necessary to develop new and efficient methods for processing and analyzing large data sets. Traditional method of data processing and analysis, such as manual data entry and analysis by experts, are no longer viable option given the massive amount of data that are generated on a daily basis. Data mining has emerged as a powerful tool for managing and analyzing large data sets with the potential to transform the way businesses and organizations operate. One of the key challenges facing data mining is the need to process and analyze large data sets in a timely and efficient manner. This requires the development of algorithms and technique that can handle such massive amounts of data generated by modern applications. As datasets grow in size, it is becoming increasingly important to develop scalable and efficient methods for data mining. Another challenge facing data mining is the need to deal with noisy and incomplete data. The quality of data can vary significantly depending on the source and the method of collection, which can lead to inaccuracies and errors in data analysis. This requires the development of technique for handling noisy and incomplete data, such as data cleaning, and data normalization. We have been discussing big data, data mining, and big data mining. So let's look at its use and meaning with respect to parallel computing. In this section, we'll be discussing the use of parallel computing environments in big data mining. As you know, big data has become increasingly prevalent in recent years, and traditional data mining methods have become inadequate for processing and analyzing these large data sets. So, this is where parallel computing comes in. It allows us to distribute the workload across multiple machines or processes, enabling us to process large data set much more quickly and effectively. So in this slide, we'll be discussing, throughout this presentation, we'll be discussing two main methodologies for utilizing parallel computing in big data mining. That is the distributed procedure and the MapReduce based procedure. We'll be comparing and contrasting the two methodologies and analyzing their performance and efficiency on two large multi-class datasets. But before we dive into the detail, let's take a step back and go into some basic concepts and background information. First, let us understand what exactly is data mining. So, data mining is the process of discovering patterns and insights from large data sets. This process involves various techniques and algorithms, including classification, clustering, association rule mining, and more. Next, let's define big data. So, big data refers to datasets that are too large and complex to be processed using traditional data processing methods. These datasets are typically characterized by three V's: volume, velocity, and variety. Volume refers to the sheer size of the dataset. Velocity refers to the speed at which the data is generated and processed. And variety refers to the different types of data, such as structured, unstructured, and semi-structured data. So now why is big data mining important? Big data mining allow us to gain insights and knowledge from massive amount of data that would otherwise be impossible to analyze using traditional methods. These insights can be used to make informed decisions, optimize processes, improve product and services, and much more. However, processing and analyzing such large dataset can be a daunting task. Traditional data mining method, such as sequential processing, can take a long time and may not be able to handle the scale and complexity of this big data. This is where parallel computing comes in. So, parallel computing involves dividing the workload across multiple machine or processes, allowing us to process and analyze large data sets much more quickly and efficiently. This approach is particularly useful for big data mining, where the data sets are too large for a single machine to handle. There are two main methodologies for utilizing parallel computing in big data: the distributed procedure and the MapReduce based procedure. The distributed procedure involves manually dividing a large dataset into subsets, each handled by a specific learning model on a single machine, with the final results combined. And the MapReduce based procedure utilizes the map and reduces the process and a master to manage computing resource across a cluster. So in the next section, we'll be discussing these two methodologies in more detail and compare their performance and efficiency on large multi-class dataset. So the previous slide has given us an insight into the background of the paper and the importance of data mining. Now, we will discuss the data mining process that has been implemented to achieve the objective of this study. The data mining process is a set of sequential steps that are performed to extract useful information and patterns from large datasets. The data mining process involves several steps, including data processing, data cleaning, data transformation, feature selection, algorithm selection, model evaluation, and result interpretation. The first step of the data mining process is data pre-processing. In this step, the data is prepared for analysis. This involves data cleaning, which is the process of identifying and removing incomplete, inconsistent, or irrelevant data. Data cleaning is a crucial step in the data mining process as it ensures that the data used for analysis is accurate and reliable. Once the data has been cleaned, the next step is data transformation, where the data is converted into a form that is suitable for analysis. This can include data normalization, where the data is scaled to a normal range to remove any bias. The next step in the data mining process is feature selection. So, in this step, the most relevant feature or variables are selected from the dataset. So this is done to reduce the complexity of the analysis and remove, and it also to also improve the accuracy of the results. Feature selection is crucial in machine learning as it helps to reduce the overfitting of the model. After feature selection, the next step is algorithm selection. In this step, the appropriate algorithm is selected for dataset and the problem at hand. There are various algorithms available for different types of data mining problems, and selecting the right algorithm can significantly impact the accuracy of the result. Once the algorithm has been selected, the next step is model evaluation. In this step, the performance of the model is evaluated using different evaluation metrics. This is done to determine the accuracy of the model and to identify any areas where improvement can be made. The final step of the data mining process is result interpretation. In this step, the result of the analysis are interpreted to extract useful insights and patterns. The insight obtained from the analysis can be used to make data-driven decision and improve business operation. Now that we have discussed the data mining process, let's take a closer look at how it is implemented in this study. So for this study, uh, we use two different. Uh, we have used SVM to as the model and to basically analyze two large multi-class data set. And also we have used two different mining procedures to analyze large multi-class data set. The first procedure was distributed approach and the second procedure was the MapReduce based approach. In the distributed approach, the data was divided into subset and each subset was handled by a specific learning model on a single machine, with the final results combined. This approach was used to analyze the two public dataset, the cover type dataset and the person activity dataset. We'll be discussing these two datasets in detail in the next slide. In the MapReduce based approach, the map and reduce process was used along with a master to manage computing resource across a cluster. Both the distributed and MapReduce based approach were used to analyze the same dataset, to compare their performance and efficiency. The objective was to determine which approach provide better result for large multi-class dataset. In the next slides, we'll be discussing the implementation of distributed approach and the result obtained from the analysis. We have taken two publicly available datasets from UCI machine learning repository, one being cover type dataset and other being the active person activity dataset. Both these datasets are multi-class classification problem. We can predict the forest cover type by only using a cartographic variable in the cover type dataset, whereas we can identify one of the four tags using a activity person activity dataset. The cover type dataset is a multi-class classification problem that aims to predict forest cover type based on various environmental variables. The dataset contains information on the geographical location, elevation, slope, and other attributes of the forest cover. The dataset has seven targets, which represent seven different forest cover types. The dataset contains a total of 581,012 instances, and each instance has 54 attributes. The person activity dataset, on the other hand, is a human activity recognition problem that aims to classify various human activities based on sensor data. The dataset contains information on the activity performed by individuals such as walking, sitting, standing, etc. The dataset has 11 target class and the dataset contains a total of 164,860 instances, with each instance having 8 attributes. We have used these two multi-class datasets to compare the performance of distributed and MapReduce procedure. We have divided both the dataset into 90% training and the remaining 10% as testing data to evaluate the metrics of both procedures. We computed the accuracy of SVM algorithm used and the time it takes to train and test the data on both the multi-class dataset. For the distributed procedure, we have divided the dataset into 10, 20, 30, 40, and 50 subsets, where each subset is mapped to one node for the training, whereas training whereas for training the dataset in MapReduce procedure, we have a computer server set up with 10, 20, 30, 40, and 50 virtual machine, that is nodes. So now let's move on to the system and software requirement. To effectively classify a multi-class dataset using distributed parallel processing and MapReduce methodology, there are certain minimum system requirements that need to be met. These requirements ensure that the system has enough processing power, memory storage, and software to handle the large amount of data and perform the necessary computation. First and foremost, the operating system of the machine must either be Windows or Linux based. This is because the software required for distributed parallel processing are designed to work on these two operating systems. The processor of the machine is also important, and a quad core processor with at least 2.5 GHz clock speed is recommended. Memory is another important consideration, and the machine should at least have 16 GB of RAM. This is because the data used in classification process is typically large and a significant amount of memory is required to handle it efficiently. Storage is an important consideration, and the machine should at least have 500 GB of free disk space. Finally, certain software programs are required for the distributed parallel processing and MapReduce methodology to function properly. These programs include Hadoop, Distributed File System (HDFS), Apache Spark, Apache Mahu, and Apache Hive. These program software are designed to handle large amount of data used in classification problem and perform the necessary computation efficiently. So in this section, we'll discuss the finding of our experiment on the cover type dataset using both the distributed parallel procedure and the MapReduce based procedure. The main goal of the experiment was to compare the performance and efficiency of both methodology in handling large multi-class dataset. As shown in figure 1, the distributed parallel procedure outperformed the MapReduce based procedure in terms of classification accuracy. The graph clearly shows that the accuracy of the distributed procedure remains stable and consistent at around 95% even when we increase the number of nodes. This indicates that the distributed procedure is more stable and efficient in providing high classification accuracy for SVM classifiers. On the other hand, the SVM classifier based on the MapReduce procedure shows a variation in accuracy as we change the number of nodes. This can be attributed to the increase in communication overhead between workers as the number of node increases. This means that the distributed procedure is more efficient and faster than the MapReduce based procedure in handling large dataset as shown in figure 2. Figure 2 shows the cost of training and testing the SVM based distributed and MapReduce procedure. The graph clearly illustrates that the distributed procedure takes only 1 or 2 minutes during the classification training and testing step, while the MapReduce based procedure takes around an hour when 50 nodes are used. So now in this section, we'll discuss the finding of our experiment on person activity dataset using both the procedure. Figure 3 shows the classification accuracy results of person activity dataset for two mining procedures. It is observed that the accuracy of the MapReduce based procedure gradually declines as we increase the number of nodes from 10 to 50. This degradation in performance is more pronounced in this dataset than in the cover type dataset as we increase the number of nodes. On the other hand, the distributed parallel procedure uh, the highest classification accuracy of 98%, and the accuracy remains almost stable irrespective of the number of nodes. This suggests that the distributed parallel process outperformed the MapReduce based procedure for complex multi-class classification problem. Moving on to figure 4, it illustrates the computation cost of the distributed and MapReduce based procedure for the person activity dataset. In this case, in the case of distributed process, as we increase the number of nodes, the computation cost decreases. However, it is the opposite in the case of MapReduce based procedure. This indicates that we do not need a large number of computer node to increase the computation and classification accuracy of the MapReduce based procedure. Thus, unlike the distributed parallel procedure, we can use a a less number of nodes to achieve high accuracy and low processing time for map reduce based procedure. The dataset used in this study, namely the cover type and person activity dataset, are characterized by large number of data samples and are multi-class classification problem. For such large and complex dataset, the most effective and efficient choice is the parallel distributed procedure, as it yields the highest rate of classification accuracy and requires the least processing time compared to the MapReduce based procedure. The result suggests that the distributed procedure is the superior method for data mining, particularly for dataset with complex characteristics such as large volume of data sample and multi-class classification problem. Thus, our findings indicate that the distributed parallel procedure is more efficient and effective choice for data mining than the MapReduce based procedure, particularly for large and complex dataset. Moving on to the conclusion, the main goal of this study was to compare the performance and efficiency of the two procedures. To achieve this, we have conducted an experiment on two large public dataset, that is the cover type and the person activity dataset. The result of the experiment showed that the distributed parallel procedure outperforms the MapReduce based procedure in terms of classification accuracy and computation efficiency. The result also indicate that the distributed parallel procedure is effective and faster than the MapReduce based procedure in handling large datasets. As we increase the number of nodes in the distributed parallel procedure, the computation cost decrease and the processing time almost remain constant. On the other hand, in the case of MapReduce based procedure, the processing time gradually increase as the number of nodes increase due to increase in communication overhead between workers. In conclusion, the result of the study suggests that the distributed parallel procedure is superior method for data mining, particularly for dataset with complex characteristics such as large volume of data sample and multi-class classification problem. The future work can include testing on various large dataset, examining other classification techniques, and investigating the impact of different computing hardware environment on these procedures. Overall, this study provides valuable insight into the performance and efficiency of distributed parallel and MapReduce based procedure for big data mining. Thank you for your attention, and I hope our finding will be useful in your own research and application.